Hello viewers, welcome to Strength of Materials video lectures. So in this class I'm going to discuss on principle of superposition. The problem statement is a bar is subjected to a point load as you can see in this given figure, and the force P2 is to be calculating, and total elongation on the bar is to be known, and the provided values of P, that is P1, provided values of that is P1, which is 60 kilonewton, and P2 is to be calculating, and then which is unknown, and P3 is 500 kilonewton, and P4 is 150 kilonewton. So out of this we need to find the P2. So once we know the P2 value, then we can substitute here and we can able to calculate the total elongation of the bar. So element AB, element BC, and element CD. Area A1 for element AB, which is 650 mm square. For area 2 of an element BC is 3000 mm square, and area 3 1400 mm square, right? So and corresponding length, say we can take L1, which is 140 centimeter, L2 is 75 centimeter, and L3 which is 100 centimeter, right? So here we need to convert all these values from centimeter to mm, since area is given in mm. And now the Young's modulus they have given as E equal to 2.1 times 10 to the power 5 Newton per mm square. This is the Young's modulus value which is given. So now our aim is to get this value of P2. To get the value of P2, what I need to do? So what I will do, I will take this P1 and the direction, and P3 in the same direction. P1 and P3 are in the same direction. I will take this P1 plus P3, and P2 and P4 are in the other direction. So I will take, that means these two forces must be equal, that is P2 plus P4. Then only the structure given figure or given element is in equilibrium. So P1 is having 60 kilonewton plus P3 is 500, P2 is unknown, plus P4 is 150. So out of this it is 560 minus 150, which is equal to P2. So P2 can be written as 410 kilonewton, right? So in this way we can able to get the value of unknown. So how we have calculated? We have taken these forces in this direction and these forces in this direction. So now our aim is to get the total elongation. To get the total elongation, we need to know how the forces are acting on each element, right? So for first element, if I take element AB, right, the element AB I am taking now. So the P1 force is acting in this direction, right? The P1 is 60 kilonewton. I will take this load value directly. So 60 kilonewton. If this element to be in equilibrium, there must be an opposite 60 kilonewton load for an element AB, which has a length of, so I will write this in a mm, 1400 mm. So now element BC is to be observed, right? for element BC, I need to know how much total load is acting on each face on of the element BC. So for that, what I do, I will take this sum. So P2 is acting in this direction towards the right, and the sign convention is referred in this calculation is in this direction. I am taking the plus sign, and in this direction, in towards left, I am taking the negative sign. So here what I do, I will observe the given statement, right, the given statement towards my right. So I will take this as plus. So P2 is 410 kilonewton, and now I will get to this one, the face BC, this face, which is again in this direction towards my right. So I will write plus 60, and for the face B, which is to be calculated, which is unknown. So for that, what I do, I will take this x equal to 410 minus 60. So it will be 350 kilonewton. So this 350 is positive now. So the positive is acting towards my right. So on this face, I am going to take this 350 kilonewton, and towards opposite to that 350, because the material or element should be in a equilibrium. Okay, so now for element BC, for element CD, now, so what we need to do, I will take this element C to D. For element CD, I need to calculate the forces acting on each face. So here what I do, I will refer the given statement. On the given statement on the face C, the force is acting towards my left, so which is minus. So minus, which is P3 value is 500, P3 it is 500 minus 500, and here on this face it is 350, on the face of plane element BC it is 350. So again that is in the towards my left, minus 350. So on this face it is x, so which is unknown. So x is equal to minus 500 plus 350, minus 500 plus 350, which is minus 150 kilonewton. So minus means towards my left, so towards my left it should act, which is 150 kilonewton. So towards my left in the sense with reference to the observed directions, sign values, right. So if this material to be in equilibrium, I must apply a load opposite to that, 150 kilonewton. So now on element AB, on element BC, and on element CD, we got all the values of loads which are acting. So now I need to take the total elongation. So how do I take the total elongation? Total elongation, which is equal to, so what I can write, P1 L1 by A1E plus P2 L2 by A2E, since E is common for all the element. So P3 L3 by A3E. So now if I substitute P for the first load, first element is 60, and I am substituting in newtons, and L is 1400 mm, and given cross section area is 650, and Young's modulus is 2.1 times 10 to the power 5. Similarly for second element, which is P2 L2 by A2E. So P2 is 350, right. So here I will consider this signs also. So this part is acting as a tensile, as a compression. as a compression. So if it is compression, then this sign must be a negative, right? This sign must be negative. So this is minus. After the element 2, we got element 3, which is tension, that means positive, tension force, which is positive. So that means for compression it is taken as negative sign, for compression for tension it is taken positive sign. Since the tension makes the element to elongate, which adds to the existing length, and compression makes the elements to compress or squeeze it. So in that case the length of the element got decreased, so that is why it is minus. So now here also it is minus, right? So to get this minus, 350 times 10 to the power 3 times L2. So length of the second element is 75 centimeter. If I convert that to mm, it is 750 mm, and A3 given is 3000, and E is 2.1 times 10 to the power 5. Plus for element 3, for element 3 the total load applied on the element is 150 times 10 to the power 3 times, the length is 1000 mm divided by the cross section area given is 1400 times 2.1 times 10 to the power 5. So now the total elongation is observed. For this it is 0.615 minus 0.416 plus 0.510. So the total elongation is 0.709 mm, which is tensile in nature, that is the total elongation. So in the question what they have asked the calculate the force P2 and the total elongation of the bar, right? So P2 what we have calculated, so result P2 which is equal to 410 kilonewtons, and total elongation which is equal to 0.709 mm, which is tensile force or tension you can write. So this is what the result from the given data. Thank you.